I think it's interesting how simple the basis for this entire paper is. You know, they're basically like, hey, it's 2006, and we have never considered up until this point that a police officer's ability to even engage in racial profiling is dependent on how light it is outside.
Hello, everyone, and welcome to In Plain English, the podcast that's all about making science approachable, open source, and jargon-free. I am your host, Jamie Moffa, and today we are going to be talking about the paper Testing for Racial Profiling in Traffic Stops from Behind a Veil of Darkness by Jeffrey Grogger and Greg Ridgway. And so joining me as our expert for this episode is Luke. Luke, would you like to introduce yourself?
Sure. I am Luke Brinkman. I'm an empirical microeconomist. I'm a fifth-year PhD student here at WashU, primarily studying the criminal justice system.
Great. And then our non-expert guests are Sofia and Grace. Would you each like to give a brief introduction?
Yeah. Hi, I'm Sofia Angulo Lopera. I'm a first-year PhD student in neuroscience, also at WashU. Thanks for having me.
Yeah, thank you. Grace?
I'm Grace Moore. I'm a second-year neurosciences PhD student here at WashU, and I study somatosensory biology, which is quite different from the topic at hand today, but I'm interested to learn more from this paper.
Great. Well, so without further ado, Luke, let's talk about the paper.
Yeah, absolutely. So this paper is... The reason that we're talking about this paper today is to give you an illustration of how economists, statisticians, other empirical researchers try and get at measuring bias. So to that end, I'm going to kind of start us off a little bit in the middle of the paper. I guess not really the middle. I'm going to start us off with the lit review because there's a few different approaches to this that have been tried over time. And I chose this paper in particular because I think it's a really interesting approach. But to kind of show you how difficult this problem is, let's talk a little bit about other ways we try and measure bias. So the thing about empirical economics is that whenever you consider a particular study, the focus is going to be very, very narrow, right? If we're going to be able to summarize absolutely everything with data, we're going to be looking at sharp variation. We're going to look at very specific situations. And so the methods used are always going to be very dependent on the setting that you're in, right? So this leads to a few different approaches to what it means to try and detect bias. One of the more famous approaches to this is the concept of an audit study. So these studies that have been done to see if the race of an applicant for a job or renting an apartment has an effect on their likelihood of being approved, right? There's this famous study where researchers created a whole bunch of fake resumes and then made the name either noticeably African-American in origin or, not so obviously connected to a particular race, and then very simply saw if they were getting callbacks at higher rates. Another key model for looking for bias is this notion of an outcome test. So the outcome test is relevant in particular environments where you're having a decision maker make a binary decision, and the result of that binary decision is recorded at least part of the time. That probably doesn't make a lot of sense, so let me give you a more concrete example. So a setting that I study quite a lot is that of bail in the United States, right? So so that maybe there's some complications if we want to talk about cash bail or anything like that. But imagine a world in which a judge looks at somebody accused of a crime and simply says, you either get to go home while waiting for your trial or you don't. You're going to be incarcerated up until your trial. And the judge does not like to incarcerate people, but the judge even more dislikes letting somebody go and then discovering that they don't show up for trial or they commit a new crime while out on bail. The idea of an outcome test is that there is information within the outcome of this decision, right? So suppose that a judge is unbiased and that black and white defendants are totally equivalent in their likelihood to commit a bail violation if released. if this is the case, then if you look at the rates at which released defendants commit violations, they should be equal across race. However, the picture is a little bit more complicated than this, because typically what we have access to in these sorts of environments is the average outcome rather than the marginal outcome.
Mm-hmm. So the idea, like the if you're looking at two different groups of defendants, they're not in fact equal in their likelihood to commit a bail violation in the example you're giving. So you have to try to figure out, like, basically what is your reference population and like how you're making your comparison, because you just can't say like, oh, judges hold Black people without bail more often than white people, and thus they're biased because they're working with either data or their, historical experiences that's maybe not reflective of the actual situation.
Yeah, you're absolutely on the right track. So kind of the additional layer of complexity that I've not formally introduced here is that judges don't have perfect information, right? So typically how we conceptualize this in econ is we say that they receive a signal from the defendant. So suppose every time they look at a defendant, they could calculate a probability that that defendant is going to commit a bail violation. And that probability is accurate in the aggregate, right? If you saw 100 defendants with a 50% probability, then they would, in fact, if all released, commit a violation 50% of the time. What would actually be indicative of bias is the judge having a different cutoff value across race, saying, I'm going to incarcerate all white defendants that have a chance of committing a violation of 50% or higher, but I'm going to incarcerate all Black defendants with 30 or 40% probability. Right. And so when we look at the average outcome among the released defendants, we're not actually able to estimate the marginally released defendant's probability.
What does the marginally mean?
Marginally here means the defendant who is released on the margin, the defendant who has exactly the cutoff value in their signal.
Yeah, that seems hard to measure.
Yeah. And usually when I explain this, I have like a bunch of graphs and I draw the distributions for you and it's a little bit clearer. But OK. All of this is pretty much to say that it's really difficult, if we're going to be very precise in our methods, to credibly say, based on data, whether or not bias is present. And this paper takes a very interesting stab at this problem in the realm of how police officers choose to stop a driver who may or may not be committing a traffic violation. And the way that they do so is they take advantage of the fact that for a police officer to be racially profiling a driver, they have to be able to observe their race. And whether or not they're able to observe their race is going to, at least some extent, depend on how bright it is outside. Okay, so to give a little bit more detail on kind of the specifics of this study, these authors are working with data out of Oakland in the early 2000s. This is a point in time in the U.S. when racial profiling is becoming more and more discussed politically, socially, etc. And in fact, the Oakland Police Department was recording data on traffic stops in response to accusations of racial profiling so that oversight committees could keep an eye on them and see if this was an actual problem or not. Something that is generally true in economics is that we have models that work under perfect circumstances, and we have models that we can actually estimate, right? And this is kind of a key difference here. Okay, so the very basic idea of this, as I've already explained, the ability for an officer to racially profile a driver is dependent on being able to observe them visually. And so kind of this very simple piece of logic leads to the idea that if race is an input in an officer's decision to stop a driver, Black drivers should be disproportionately stopped when it's light outside relative to when it's dark outside. Easy enough. Now, they do a lot of very fancy math to show the fact that though kind of an idealized test would depend on directly observing whether or not the driver's race is visible, we can still produce useful results simply conditioning on whether or not it's light outside. And kind of the key difference between this idealized test and this feasible test is that in the idealized test, the result would be a magnitude. We would in some way be able to measure the size of the bias in this setting. However, the feasible test, though it can't give you any sort of magnitude, should be able to detect the presence of bias at all.
And it can't give you a magnitude because you don't know, like, whether the driver actually is visible or not.
Yeah, exactly.
There's a lot of things that could affect that. Someone's windows could be tinted in the daylight, and so you wouldn't be able to tell. Or there could be really bright streetlights at night, and so you'd be able to tell anyway. 1,000%.
So streetlights are a potential confounding factor that they explicitly mention. They also talk about, sometimes the look of somebody's car is somewhat indicative of what race they are. There are all sorts of ways in which, darkness is not going to be the perfect veil over the eyes of these police officers. But as long as the relationship is there and somewhat significant, we can still do a test that is useful.
Yeah, I actually did want to briefly discuss the moment in the paper where they talk about how a cop could possibly use different facets or different qualities of the car that they're viewing as different, I guess, to use your jargon, or not jargon, since the podcast is supposed to be jargon free, but to use your word as signals for what the driver's race could possibly be. And I guess I wanted to ask you, as the resident expert, how useful you think their application of that idea to this actual question of whether, racial profiling in Oakland at this moment in time in 2000, I don't know, 2002 or 3 was it, was going on.
The question is whether or not I think the test has the power to detect bias if it's there.
Yes.
Yeah, so that's a great question. Something that is very much true in statistics and economics is that the more data you have, the better, right? And their data is somewhat limited in size. So something I was actually going to bring up later in the paper, but now is a great time to do so, is that this paper is so well known because it was the first to attempt to use this sort of methodology. But there certainly have been more recent papers that have revisited the methodology with new and improved data. So in particular, there's this paper that came out in 2020 by Pearson et al. This paper took a massive amount of work to produce. There's something like 11 co-authors listed on it. Part of why there are so many people involved in this paper is that it's not just economists, it's also computer scientists and data scientists. And the reason they have a need for all these different sorts of academics is that this is a team working at Stanford who produced what is known as the Stanford Open Policing Project, which through the use of Freedom of Information Act requests and stuff like this, we're able to put together information on traffic stops from all 50 states and the 100 largest cities in the US.
Wow.
And so this paper essentially revisits the methodology of Grogger and Ridgway, except that their sample size is 100 million police stops instead of 6,000, right? So what we're going to see through Grogger and Ridgway is that they are not ultimately able to conclude that there is any sort of bias present. However, Pearson et al. Very strongly find that there is bias present in police decisions on who to stop. And in fact, they're able to do better than Grogger and Ridgway, not just through their sample size. Partially because of their sample size. They're able to use an even more specific methodology that rather than using this. So Grogger and Ridgway, in order to exploit this difference that darkness has on the ability of police to observe race, they use traffic stops from what they term the inner twilight period, from about 5 p.m. to 9 p.m. This is the time of day that, depending on the time of year, could be either dark or light.
That was pretty clever, I thought. I liked that.
Yeah, it's cool. I mean, this whole paper is kind of cool with its methodology.
I actually had an issue with that.
You did? Okay, let's hear about it.
And my issue with that was that I think there could be a potential confound there with the fact that these might be times when people are either leaving their workplace or are like going to their workplace if they have like a night shift. And so I was thinking, well, there might be a higher likelihood of people committing traffic violations if you're potentially like, again, rushing to get home or rushing to get to your workplace. And so I almost thought like I would have liked to have seen maybe like a longer an intertwilight period and then an actual twilight period. But I understand why they chose that set of times.
Well, and to your point, if you believe their model, that shouldn't actually be an issue. It is totally, everything that they do is conditioned on the time of day. So as long as you are equally likely to be rushing to work at 5 p.m. in June as you are at 5 p.m. in December, then their methodology is still valid.
That's true. That is true.
And the authors do mention the fact that there are differences in the like racial behaviors of driving at different times of day based on the hours that they typically work. So it seems like this wasn't a, confound that they hadn't thought of and implemented into their model.
For sure. I guess I was thinking I was wondering, and I'm not an economist, so I was thinking like, how would I have designed, like what other time could I have chosen? Or like, how else would I have addressed, like if 5 to 9 was going to be the time interval, which I did like, you're right. I did like that they talked about those concerns briefly, but I was wondering how else would I have addressed that concern of people, like a way, I guess, to get almost like a full survey of different driving behaviors.
So did the newer study use the same time interval or did they expand the time window?
No, they narrowed the time interval. They actually only used the few days surrounding daylight savings time.
They did say that at the very end.
Yeah, this is an idea that they mention in their conclusion, but they absolutely don't have the sample size to make it happen, right? Like, I think they don't even have a full year of data, right? So they have the fall change in the clock time. But yeah, certainly nothing that would allow them to use this sort of methodology. But so to introduce a little bit more jargon, if I may, the authors make a lot of use of this term, the risk set. So the risk set is simply the set of drivers who could be pulled over. So it's people that are driving, who are on the roads, and who are committing a traffic violation, right? Because police officers have to have a reason to pull you over. So as long as you think that the racial makeup of the risk set is not different, conditioning on time of day, but not whether or not it's dark outside, then their methodology is valid. And then Pearson et al., with their larger sample, are able to use just daylight savings. So as long as you think that the composition is the same, 5 p.m. on the day before daylight savings and the day after, then we're good to go.
Yeah, that's like a kind of even a stronger case because you're like, yeah, if someone's coming home at 5 p.m. from work on October 20th and the next day at 5 p.m., they should still be coming home from work unless it's a Sunday. The only difference is that we humans have decided that 5 p.m. is now at a different time.
Right. And it's possible that whether or not it's light or dark outside is going to change the way you drive to some extent, right? Like that's pretty logical. Maybe you're a little more willing to take risks when you can see clearly or something like that. But as long as those differences aren't correlated with your race, it's not going to matter for their methodology.
And you said in the Pearson et al. Paper, they used a little bit different methodology than the paper we're looking at here. If they are looking at, all of these cities across the country, did they go back and look at Oakland specifically and find a different result than in this paper?
Oh, that's a great question. I am not certain of the answer to that. My guess would be that it's not something that they consider explicitly because kind of the whole point of their study is that they have so many more observations. And the reason they have so many more observations is that they're pooling across locations. Right. So if they tried to go back to Oakland, they might run into the exact same sort of sample size problems that Gardner and Ridgway are having.
But then their conclusion. So this conclusion is limited in part by the fact that it's only about Oakland. Right. Their conclusion is maybe limited by the fact that while they can say that in the whole country, there is racial profiling happening in traffic stops somewhere. They can't say whether New York City is a bigger contributor to that than Los Angeles or Oakland or.
Yeah, I'm surprised to hear that they aggregated everything and didn't also look at city specific, practices within the policing to see if there was racial profiling given the socioeconomic conditions in that city, the racial demographics in that city. It seems like they could. I like that they got this huge sample size, but I also think it would have been interesting to look at the individual cities' results as well.
That's super legitimate. And I should note that I have looked at Pearson et al. A little bit less recently than Grogger and Ridgway, since that's what I was like specifically preparing for this podcast. So if I'm saying something about Pearson et al. That is inaccurate, my bad, you guys.
Pearson or et al. Sorry.
Yeah. I mean, even with a brief skim through Pearson et al., I do see some graphs that are broken out by state. So it is very possible that they do at least consider differences by state.
So besides changing it to only the day before and after daylight savings time, what else did they take from this paper as maybe not the optimal way to measure this?
So the basic logic of it is very much the same. Any other differences are going to be fairly technical. So something that we haven't gotten into in a lot of detail is how Grogger and Ridgway are trying to control for the particular time of day that it is, and that involves very specific methodological decisions. So something that we were talking about before we went live is that Grogger and Ridgway use a statistical technique known as spline estimation. And that is the very particular choice of mathematical function to estimate their regressions. So maybe I should even explain what regressions are at this point. Yeah, okay. So let's talk about regressions a little bit. So in an idealized world, everything that Grogger and Ridgway are doing could be done simply by comparing the percentage of drivers stopped who are white or black when it is light or dark. However, reality is much more complicated, and they have to do things like control for where in the city you are, what time of day it is, etc. They do so using techniques known as regressions. Regressions, very simply, are, if you've ever been inside of Excel or Google Sheets or any other spreadsheet, and you had a bunch, you've created a little plot for yourself, you have an x-axis and a y-axis, you've put a bunch of little dots in it, and you want to draw a trend line that shows the general relationship between these dots is X's versus their Y's. That is a very, very simple form of regression. Now, in that case, you're using a very particular assumption that the relationship is purely linear, right? It's a straight line. But
as X goes up, Y will go up, or as X goes up, Y will go down.
And it will do so at a constant rate, right? It can't curve. It has to be straight. And so if we want to allow our techniques to be a little bit more flexible than that, then we very quickly get into very complicated statistics. And some of those statistics is the use of spline functions, which are very flexible linear functions. Something that I've mentioned to my co-host here is that one of the other main uses for splines is that they're used in animation in movies, right? Because you want to be able to represent all sorts of shapes with these 3D objects on a screen. And one way to do that is through the use of spline functions.
But we don't have to get too much more into the weeds on this. They used some fancy statistics.
They use some fancy statistics to model the effect that the time of day has on the likelihood that a driver is stopped.
Maybe we could, this will like take us in a different direction, but maybe we could talk about, there's a pretty interesting part of the paper where they talk about kind of breaking up out of all of Oakland, breaking up Oakland into different neighborhoods and looking at different like rates of stopping drivers per neighborhood. But then they also talk about this kind of like non-reporting problem that they have. And I'm curious kind of like in your field, what are some of the tools that are available to you, or like, let's say you were doing this study and you came across this non-reporting problem. What are ways in which you can deal with that?
Great question. Empirical economics is extremely specific. And I don't know that I could give you a helpful answer for like a general approach to this sort of problem. But I can certainly say that this is a kind of problem that crops up absolutely all the time. Especially if you're like me and you study the criminal justice system, you just have to be aware of the fact that police officers have many opportunities to file reports and they take some of those opportunities. And that's just the way that the world works. So this paper is a pretty interesting example of what you can do about that, right? Because they sort of ask the question of, okay, let's imagine that this is occurring and they have some specific evidence that it probably is, namely that oversight increased and then the number of reports magically increased at a rate much faster than, the population growth of Oakland or whatever. So what they said was, imagine that some number of traffic stops are not getting reported. Very simply, what would happen to our results if that were true? And they were able to come up with a relatively small set of assumptions under which their test is still valid. And essentially what it requires is that though some stops go unreported, whether or not a stop is unreported should be unrelated to the race of the driver. Now, it's actually pretty reasonable to think that assumption doesn't hold, right? Because if you are an officer who is engaging in racial profiling and you are choosing not to report some of your traffic stops, probably if you've stopped someone on the basis of their race and you don't find any reason to have done so, you may not want to file that report. So they get into some very fancy math to kind of ask the question of how prevalent would this problem have to be to induce the non-result that we're seeing? And so they can kind of give you specific numbers on the parameters within their model that would cause that to happen. And that is the general approach, but what that looks like is so dependent on your model that there's not kind of one way to get at it.
See, this I think is interesting because I don't see this a lot in bioscience papers where people say, here's how far we can go before we believe that everything we just said is not true. And it seems like a major point of this paper is them asserting that we have to have substantial deviation from these assumptions in order for this to really be overturned, which I kind of like that they've considered this because they're directly thinking about the implications of what people would be using this paper for. And so I like that way of thinking because I think that gives, Pearson et al. Or whoever is going to be making the next paper a really obvious jumping off point by which to be like, okay, well, if we do implement this into our next study, is this actually true? If we do maintain these assumptions, if we overturn these assumptions. So yeah, is that common in fields or in papers in this field?
Yeah, that absolutely is common. And I think that's really kind of driven by the nature of the research, right? Because if you're working in some sort of biological science where ideally, I don't know what your day to day looks like, but you guys have the blessed opportunity to conduct randomized control trials, right? And I do not. And so because of that, I have to do all sorts of fancy math tricks to learn anything at all. And ultimately, I'm going to be making assumptions that simplify the setting that I'm trying to study. So you have to be very aware of the limitations of the assumptions that you're making to be doing reasonable, credible research.
Right. You can kind of assume whatever you want and then get the results that you want, but then those assumptions might not actually be in any way reasonable. They're always going to be a simplification of reality. But I think here they actually, it looks like did their due diligence and were we're going to actually test these assumptions, or not test, but stress the model almost and see how much do these assumptions have to not hold for our conclusion to just be totally wrong, which is not, even though in experimental biological sciences, we're not often making models with those kinds of assumptions. I think we also don't really carry over a lot of that, let me try to prove myself wrong.
Sure. Yeah, that's definitely something that I like about economics, kind of the recognition of the gap in between the world that exists on your piece of paper and the world that exists in actuality. Mm-hmm. I'm certainly not going to claim that this is a problem that's dealt with perfectly by economists.
I think it's interesting how simple the basis for this entire paper is. They're basically hey, it's 2006, and we have never considered up until this point that a police officer's ability to even engage in racial profiling is dependent on how light it is outside.
Yeah.
Which I was like stunned by the fact that, I mean, obviously there's these very obvious things that take a long time to answer in any field due to technical limitations or, conceptual advances that haven't been made yet. But I thought it was interesting that like something that seems so elementary, it's the basis for a pretty fundamental concept, and from my understanding in the field.
Yeah, that's super fair. I think part of that is that, so I'm an economist, right? So I'm mostly aware of the economics literature on these sorts of topics. And the study of crime and bias and stuff like that is something that is pretty new to econ. So there's this very famous economist named Gary Becker. If it were not for Gary Becker, I would probably not be doing what I do right now, because he's credited with really broadening the scope of what subjects are deemed appropriate for economists to study. So he both wrote a very famous monograph on the economics of crime and a monograph on the economics of discrimination. And he really kind of blew those fields wide open for economists. And he wrote both of those. I believe one came out in the 50s and the other came out in the 70s.
Wow.
So yeah, economists had been considering these sorts of problems for a few decades at the time that this paper came out. I came into grad school not really aware that this was like fair game. Mm-hmm. I knew that I wanted to do something empirical, but didn't really know where I was going to end up landing. And I was thoroughly bored by like stock markets and stuff like that. And I happened to take a class on the econ of bias and crime during my second year. And here I am. So thank you, Gary Becker.
Yeah, I guess so. Something that I wanted to ask about was that this paper, I guess for lack of a better idiom, seems very black and white. That one problem I saw with the whole veil of darkness assumption was that it relies on the idea that if it were light out, police officers would be able to tell what someone's race was by looking at them, which is sometimes
I had actually a similar concern. I wrote a couple of times. It was like, wouldn't this also be true? Like when they were talking about all the different limitations of like, the things that make it harder. They talk about unobservable factors like daytime glare, nighttime street lighting, angle from which the police view oncoming traffic. Is that not also a problem in the daytime to be able to, at a glance, determine a driver's race? I don't know that they necessarily address that.
They do to some extent, because kind of their key insight is that the relationship between whether or not it's light outside and whether or not you can see a driver's race doesn't have to be perfect. It just needs to exist. So the weaker that relationship is, the less power their test has. So power used in this sort of statistical sense refers to how much data and or how large of a magnitude of an effect need to be out there for your test to detect something significant. So if that relationship is weak, then their test has fairly limited power.
And you need a lot of data in order to detect any kind of bias.
Or extremely discriminatory police officers.
Right.
Which we may have.
Obviously, like the largest conversation is around like anti-Black discrimination by police, which, yes, obviously. But at the same time, like, yeah, I still don't know how this holds up either in cities where the predominant sort of like racial makeup is not like either Black or white.
Sure.
Or in cases where police officers are observing a lot of drivers that are like mixed race, or like they wouldn't be able to tell because ambiguous when they're driving.
Yeah, that's super fair. And I think something that's interesting about this arena of study is that, since economists first started writing about these sorts of things in the late 20th century, we as a society have developed much more complicated, layered conceptions of race kind of in general. Mm-hmm. However, ultimately, when you're talking about bias, what really matters is not how the subject conceptualizes their race, but how the police officer does, right? Which is probably going to be a little bit simpler.
Right. And obviously, you're never going to be able to have a model that's like taking into account all of these different minutia of race, because it's a very complicated concept. Yeah, I just like pulled that out as another possible way that this model would be weakened like another way that the relationship between visibility and percentages of like Black drivers stopped would not have as strong of a correlation. So what you were saying earlier of like it has less power.
Yeah, that's super fair. And I think kind of the, visual nature of their tests probably partially drives their decision to focus exclusively on the Black, non-Black binary, because people who are Black tend to be so more visibly than people of other non-white races. A lot of papers in this space do also consider Latino drivers, which has been a matter of contention kind of in the US at various points in time. There were in particular some papers that came out of, I think, Pennsylvania, where cops were very explicitly pulling over Latino drivers at far higher rates than anybody else because they were like, oh, they're Latino, they're carrying drugs. Right. So like this is absolutely, not simply a Black, non-Black question or problem. But I think, what they can infer is driven by the particular nature of the test they're carrying out.
Right.
I guess it'd also be interesting to think about how this paper would be written differently today, considering like the, I think, more massively expanded array of like surveillance tools that police have at their disposal. And also the ways in which like not only, I guess, specific technologies that exist now that didn't exist in 2006, but also like ways in which cities have changed to facilitate that surveillance, such as like there's, I think, either Grace or you also brought it up about the street lamps or the visibility. And I remember reading this paper, and I can't remember the author or what it was called now, but it talked about how kind of certain cities across the US have it's both like an environmental issue and also surveillance issue, because instead of like planting more trees in neighborhoods or allowing trees to like kind of grow and form almost like little canopies, trees are either not planted or cut down or like sheared in such a way to allow for the placement of streetlights. And so then there's kind of like an oversaturation of street lamps in specific neighborhoods to like light them up a lot more and make them more available to be surveilled.
Yeah, that's a super interesting point. And I think it kind of comes back to something I brought up right at the beginning of this whole thing, which is that doing empirical studies is easiest when you zoom in as far as you can on a very particular scenario. And so in this paper in particular, right, the setting that they're considering is there is an officer in a specific place. They don't ask the question of why they're in that place. They only consider as a car drives by, how do they choose to stop it or not? So they use the particular term of neighborhood profiling, right? They talk about, well, if officers are in primarily minority neighborhoods more frequently than in primarily white neighborhoods, then this is going to have effects that our paper is not considering at all. And what they talk about in Oakland at this particular time is that the policy of the police department was to distribute officers based off of how many service calls come out of a particular area. So every department potentially is going to have different approaches to this question, but there's a whole lot of stuff going on here that the authors just aren't placed to question.
I'm glad you brought that up, because I actually had just started thinking about how if we're discussing racial profiling specifically in the context of are you going to get pulled over and not the outcomes of getting pulled over, which the authors mention, that they didn't address, are these people going to get searched? Are these people going to get arrested? I almost wonder if spending so much time dealing with this problem isn't addressing what the consequences are that they're really trying to mitigate here. Because I don't think the problem is necessarily that you have to stop your car for a few minutes, but that these people are being wrongfully searched, arrested, the, tangible outcomes of what might happen if there was racial profiling, but that there's another step in the process where that might be happening that they're not addressing.
Yeah, that's super true. And, in Grogger and Ridgway's defense, I think they would say, there's absolutely a place for that. It's just we can only do so many things at one time.
That's outside of the scope of this paper.
Exactly. Yeah.
Classic.
But yeah, no, that's super legitimate. There are many, many angles to consider, and they are only able to consider one at this time.
And this is certainly part of it. So like the newer paper that you mentioned did find racial profiling looking on a national level, but you need to be stopped in order to be searched and arrested. So part of the problem is upstream of where they looked, which is where are the police, which we touched on briefly with the whole neighborhood profiling. And we know, or at least there are certainly other papers that have argued that police are overrepresented in minority neighborhoods. So there's the problem upstream of this paper. Then there's what this paper is looking at, which is there disparities in who is being stopped? And then they mentioned other papers that look at, are there disparities in how long people are being detained, who's being searched, who's being arrested. So I think they're making the argument that their paper is part of an ecosystem of papers looking at racial bias from an economic lens, rather than saying, like, we're going to cover the whole gamut from where are the police to who gets arrested. It's kind of a lot to do in one paper.
Well, I was going to say that there's also, like, from, I guess, the police side of it too, a sort of expectation set up that there will be more reasons to stop in these neighborhoods. As the paper mentioned, like the way that they kind of parcel out different, like, I guess, units, or the way that they allocate out police to these neighborhoods is off of these calls. And then they kind of very quickly brush it off with, like, oh, and most of these calls happen to come from minority neighborhoods. And so that's why there's an increased police presence there, again, per the paper.
Right.
And so, yeah, there's something else to examine there as well, which is like, and I wonder, like, if there could have been a way of modeling this, which is that the police's bias is indeed, like, it's not starting out, I guess, unweighted. It is weighted already by the fact that they're, you know, that they've either been assigned or that they're patrolling these neighborhoods, and that there is some expectation that has been set about what level of stops, or what level, it's difficult to get air quotes in on a podcast, but like what level of kind of like activity they can expect.
I mean, I think the specific concern about a level of activity being expected in a particular area is actually somewhat dealt with by their model, as long as we're willing to believe that police staffing doesn't depend on if it's light or dark outside, which is actually probably a fair question to ask, right? Like,
no, I mean, I think, like, if you think about, if you've ever been, and this obviously wasn't on interstates, but I think the most concrete example that I can think of is, like, if you've ever been driving on an interstate during the daytime versus the nighttime, I think there are more cops in the nighttime. Sure.
But let me reemphasize that they are controlling for time of day, but not whether or not it's light or dark outside. So as long as that level of staffing is the same at 5 p.m. in June and in December, then we're okay.
I guess, how would they obtain that sort of data about the level of staffing? Maybe that's kind of like outside of what we can answer.
I mean, I think the station will know, like, how many people they have dispatched and to where, so they could potentially integrate that into the data set.
I actually do a ton of work with data out of the Chicago Police Department that I actually observe exactly that. I see whenever an officer works a particular shift and what geographical area they're assigned to during that shift. So my assumption would be that through a records request or something like that, the authors would have access to very similar data.
But they don't explicitly include that in their model. They assume that that's the case. So they could, like, one could imagine a even more complicated thing where they actually look at, like, is that really the case that 6 p.m. in the summer and 6 p.m. in the winter have the same police assignments?
Sure. Yeah, that's super fair. And I'm unaware of what all they have access to behind the scenes. So
yeah, they did assert somewhere in the paper that the Oakland Police Department shifts are based off of time of day and not daylight. So in some way they looked into it and were like, oh yeah, they assign where their police go, but like based on whether or not it's 6 o'clock and not whether or not it's dark.
Yeah. From my own experience, police schedules tend to be quite rigid. They have a very set rotation of when they work. There is a little bit more complexity in where they work. It might be that they're going to be working at this time on this day because of their rotation. It's actually not weekly, which is helpful for a lot of stuff that we do. So they do 6 days off, 6 days on, 2 days off on repeat over and over again. So they actually cycle throughout the week. But there is an additional decision made by some sort of shift supervisor who says, okay, these are the officers that I have at my disposal. Where am I going to put them on this day? Right. Is there some big event? I think I need them in this area of town, that area of town, etc.
And we did argue at some point that by limiting the sample period and using this time of day control, that they're actually equalizing the differences in risk that would arise from like having differences in police exposure. Which that's when I started to get a little lost on how they were able to just assume that, because that's a pretty big factor that I think would challenge their assumptions here.
Can you be a little more specific about what the concern is? Or
just that they talk about that their methodology of limiting the sample period to this specific time of day somehow equalizes the differences in risk that they acknowledge do exist in police exposure based on race, but that somehow goes away based on the time of day that they've chosen.
Right, because they're arguing that risk is constant within a particular area in a particular time of day.
Yeah, I kind of wanted to ask, so they report a statistic, or they report several different statistics based on the different tests that they do, and also that they do this test across time and across different neighborhoods. I didn't see that they ever cited a number that would mean that their test was like showing that there was racial profiling or not. So they actually showed or found like kind of a negative number, meaning that like, if anything, like that there was definitely not racial profiling, and that overall like white people were pulled over a little bit more than black people. But if they had shown, but it was like negative 0.12, which seemed small. But if it had been positive 0.12, would they have also said that didn't really mean anything? Like, where's the level?
Yeah.
Okay. Welcome to my intro to statistics class.
But you can't do a t-test on these things.
They went to the extreme to say that there was actually reverse racial profiling.
Right, but
like,
how?
That was a line. That was an actual line from the paper.
They said, if anything, which to me made it sound like we didn't set our test up to test for this, so...
And we're like surprised that we got this.
Because they reiterate multiple times that this is a qualitative test and not a quantitative test, and that they use the quantitation of this then to make...
But so would even positive 0.01 indicate like racial bias?
Yeah.
So if you happen to be following along in the paper, the part of the paper that we're talking about here is table 2, where they report their specific results. And what they're finding, I don't think they explain it as clearly as they could have. They're writing for fellow economists primarily. What they're finding across the board is that their estimates are statistically insignificant. So they cannot reject the hypothesis that there is no relationship here. They say, if anything, there is racial profiling of non-black drivers because that is the direction of the coefficient that they are able to estimate, but it's not large enough to be considered significant.
But what would be large enough to be considered significant?
1.96 standard deviations or standard errors, I suppose, in this context.
Yeah, so they said that their effect size was smaller than the standard error.
Yeah.
Which was the only kind of indication that I could see about what they considered like significant or not. So I was like, okay, so maybe if their effect size had been larger than the standard error, they could have concluded something one way or another. It seemed, I don't know, it's not the kind of statistics that I'm used to. And so I was trying to find like where have they set like a p equals 0.05 kind of cutoff? Yeah.
P equals 0.05 would be equivalent to a confidence interval of 1.96 standard errors. So this is something they're kind of taking for granted that you know a little bit about already. And just didn't.
So there's an implicit cutoff.
0.95 confidence is the ubiquitous standard within economics, and they didn't even feel the need to explain that to us.
Okay. Yeah, I mean, basically what all this is saying is that they found very, very small effect sizes.
Yeah.
And none of them approached their implicit level that they didn't tell to us of how strong the effect size would have needed to be in order to indicate racial profiling or not.
Yeah, this paper is written in the Journal of the American Statistical Association. So they are assuming a certain level of stats knowledge.
It might have felt a little bit condescending to explain that to their readers.
Do you feel like the way these papers are written kind of obstruct a layperson's ability to read this and also get up to speed on social issues?
I would say certainly the Grogger and Ridgway paper. Yeah, I would say that's true. I mean, in general, I think a lot of academic writing is not written for the layperson.
Oh, I 100% agree.
Yeah.
I don't think that you're going to find that economics is an exception to that rule.
I think the direct relationship between what a layperson might be able to take from this and apply to their own life is potentially more than what we do. And so if it's becoming close enough that they're like, I get the point of this, but it's not written in a way that I really can understand what they're saying, you know, I think maybe in this field there might even be a greater need for that so that people can get more involved in, you know, their local government or social justice issues by actually looking at the science.
I was trying to look up if this paper had gotten any press, like any sort of discussion outside of economic circles on, because I had never heard of this way of measuring racial bias in policing. And I like to think that I'm the sort of person that maybe would have heard of something like this.
I think something that you have all gotten at, like mostly implicitly, is that there is a trade-off here, right? If you're going to simplify things, some of the nuance is going to be lost. And, you know, as somebody that's been thinking about economics and only economics for the last 5 years and still feels thoroughly confused a lot of the time, like there is just a cost to be paid in like attaining a certain level of understanding of all the techniques in play before you can really push the boundaries of knowledge.
Right. Yeah, obviously there's a trade-off and it's a different kind of communication.
I mean, I think that could also, like, that raises up kind of a separate question, a separate but related question about what kinds of mechanisms already exist in our fields for like making sure that the papers that are put out are as, I mean, this gets in, now this gets into a whole nother question of like, okay, what are we actually doing our science for? Is it to be thorough? Is it to be, yeah, I know. I'm sorry.
For the citation metrics.
Yeah. Or is it to get that fat 8 in text? But yeah, what kinds of mechanisms like already exist to ensure that the papers that are going to be put out are, one, understandable, and two, like, I mean, actually something that you brought up, which has really stuck with me so far, is kind of the usability of a paper like this, or its kind of direct applicability.
Yeah, in economics specifically, there is kind of this central credo of, for your paper to be relevant, it should be relevant to understanding what is good and bad policy from the viewpoint of, we use the term social planner, which is kind of a scary word, but, you know, essentially somebody working for the government, right? And I don't know that we necessarily do a perfect job of following that. In fact, I'd say we definitely don't, but having that goal, at least, I think is a good place to start.
What's one thing that you wish non-economists knew about economists?
Oh, wow.
This is a personal interview.
On a very personal level, I wish they knew that the areas studied by economists are much broader than you might expect. And if you ask me any question about the stock market, I will not be able to answer it for you. I cannot tell you where to put your money.
I wanted to ask before you go, what kind of, so you said you do research that's similar to this. What kind of research do you do?
Yeah, great question. So I have a few different projects. They're pretty wide ranging. I mostly work with data out of Chicago because that's where my advisor got his PhD. I have done a ton of work on bail and cash bail specifically. So trying to write the paper that shows that making people put money down to get out of jail doesn't actually have any sort of meaningful effect on whether or not they're going to show up for trial, and it's stupid and we should stop doing it. I actually do some papers somewhat similar. I don't study bias explicitly a lot myself, but I do study police behavior. So in particular, I have a paper right now on how police decisions to search somebody for contraband change over the course of their career. And then finally, I'll mention that a new arena I'm kind of figuring out for myself is the world of what are sometimes called pay-to-stay policies. So pay-to-stay refers to really any policy that essentially, incarceration is very expensive. We spend a lot of money on incarcerating people, and a pay-to-stay policy is any policy that tries to extract the resources to pay for that incarceration from the incarcerated person themselves.
All of the things in our society that are made with prison labor. Yeah.
I, in particular, am starting in on a new project on commissary stores within prisons and pricing behaviors within those. So an economist is very used to asking the question of, is this market priced like monopoly, which translates into very bad for the consumer. So yeah, doing stuff like that.
Yeah, that's sounds really cool.
I have kind of a last question for you, but as an economist, I'm curious on your end, how encouraged are economists to, I guess specifically in your education into becoming an economist, how encouraged are you to actually forge like policy change?
That's a good question. That's a somewhat uncomfortable question, honestly. I would say not particularly encouraged. Feedback that I have gotten on particular papers of mine has included so I am someone who's very interested in teaching specifically. I went into undergrad with a tentative plan of being a high school social studies teacher, and at some point decided I wanted to talk about this stuff at a level that would not be possible with high schoolers. And so here I am. So my goals within my research and stuff like that are a little bit different from a lot of my classmates. Most of my classmates are trying to get jobs at top tier academic research universities. And to do that, if you want to get noticed, it kind of comes back to stuff I was talking about earlier, where it's all about inventing the fancy new methodology. And so I've actually gotten pretty specific feedback on some of my work that is like, you need to not worry about writing a paper that could be written by, someone with a master's in public policy. What you want to do to get noticed is to do fancy math, essentially. So I think despite how much we talk about policy, it's not always so encouraged that you really approach things from that sort of lens.
Does anybody have anything to plug? Presence on social media, papers that you have written that you want people to read?
I recently picked up a really good book. It's called The Broken Heart of America, A Violent History of the United States. And it specifically talks about St. Louis, kind of like from its very beginning, from its very inception as a city, actually. St. Louis is pretty unique because it doesn't have just one or two colonial influences. It has three. The British, the French, and the Spanish were here. And it's really, really, so the book kind of takes you from, again, how those different influences shaped the city from the past all the way up to the present day. So if you're listening and if you're in St. Louis, no matter kind of how, if you just got here, if you've been here for a couple of years, if you've lived here your whole life, it's a really, really well-written book. And I definitely encourage you to go read it and check it out.
Yeah, I definitely will check that out. That sounds super interesting.
I'll lend it to you if you.
Oh, thank you. Yeah. Grace, do you have anything to plug?
My plug is take a deep breath. That's the whole plug.
Yay, that's a good plug. How about you, Luke?
Sure. If books that we've read that we liked a lot are on the table, that I absolutely do. And also relevant to this conversation, because I think it's very much about relates to the conversation we've been having about the usability of scholarship and the way, I think more specifically gets at the way that a lot of economists and statisticians and stuff like that try to have very clean results. And sometimes it's better to embrace the complexity of the world. But it's The Mushroom at the End of the World by Anna Tsing. It's a really excellent book, and I heartily recommend it to everybody.
Excellent. Well, everybody go check those books out. I don't think I have a specific book recommendation right now, maybe in the future. But yeah, go check those books out for sure. And thank you all for being here and being on the podcast. And yeah, we have been talking with Luke Brinkman and Grace Moore and Sofia Angulo Lopera. We've been talking about the paper Testing for Racial Profiling in Traffic Stops from Behind a Veil of Darkness by Jeffrey Grogger and Greg Ridgway. Our logo is by the wonderful team at Biographics. That's Jessica Higginbotham, Tania Lintz, and Yolanda Campos. Our music is by Sam Brunwasser. You can find more of his work on SoundCloud at Visuals Now Beats. And finally, be sure to follow us on Twitter, Facebook, and Instagram at Plain English Sci so that you never miss an episode or exciting news and updates about In Plain English. Again, that's PlainEnglishSci. Thanks once again for listening, and come back next time for another episode of In Plain English.